Hello and welcome to this video where we're going to learn about inverse functions. So let's start with a function. I'm going to take f of x equals 7x plus 2. We could draw out a function machine for this function. It would look something like this. And if you take an input, for example 4, you can generate an output by putting it into this function machine. So we start with 4, we multiply by 7, which gives you 28, and then add 2, that gives you 30, and that's your output. So when the input is 4, the output is 30. When we talk about inverse functions, we're looking for a function that reverses this process. So if we were trying to find the inverse function for this one, we could draw out another function machine, but in reverse. So the input's on the right hand side and the output's on the left hand side. So we need to try and create a function where we start with 30, but we end up at 4. So what we do is we go backwards through this function, and then every time we get to an operation, we just do the inverse. So we had plus 2 in this box, the inverse of that is subtract 2. So 30 take away 2 is 28. And then we move on to the next box. And this one was multiply by 7, so the inverse of that is divide by 7. And 28 divided by 7 is 4. And you can see we end up with the output of 4, which was the input of the original function. So the original function was f of x, and the inverse function is written like this, with a -1. This simply means the inverse function. You shouldn't confuse that -1 with a power -1. It doesn't actually act as a number in this scenario, it's just the way we write an inverse function. So if you ever see f with a -1 there of x, this just means inverse f of x. And we actually just worked out this function. We first of all subtracted 2 and then we divided by 7. So we could say inverse f of x equals x minus 2 and then divide by 7. In your exam, you may be given a function and asked to work out its inverse. There is a method that works well for this and means you don't have to draw out those function machines each time. The first step is to write out the function and change the f of x for a y. So the function here is f of x equals 8x minus 5, but I'm going to replace the f of x with a y. Then on to step 2. So step 2 is to replace the x with a y and a y with an x. And this applies to all y's and x's that are in your function. So if you have many x's, all of the x's turn into y's, and any y's turn into x's. In this case, we've just got one of each, so I'm going to replace that y with an x, so it's x equals, and then replace the x with a y, so it's 8y minus 5. And that's step 2 complete. Then we move on to step 3, which is to make y the subject. So we need to do a bit of rearranging. First of all, I'm going to add 5 to both sides. If I add 5 to the right hand side, that will cancel the -5 that's there and leave me with 8y. And if I add 5 to the right hand side, well, there's already an x there, so I just need to add 5 to that, so that's x plus 5. We've got one more step to go. On the right hand side I've got 8y, so if I divide both sides by 8, on the right hand side 8y divided by 8 is just 1y, and on the left hand side I've got x plus 5 and I divide that by 8, that's x plus 5 divided by 8. So step 3 is complete. On to the final step, step 4, is to change the y into inverse f of x. So we can just remove that y and replace it with inverse f of x. And normally when we write functions, we'd write the function bit on the left hand side. So we can just switch those last two parts around. And here's the answer. So the inverse function is x plus 5 over 8. Let's try this with a second example. So we're going to go through the same steps. we're going to change f of x into y first. So let's replace the f of x with a y. And then on to step 2, we're going to change all of the x's with y's and all of the y's with x's. So instead of y equals at the beginning, it's x equals. And then instead of x over 5, it's y over 5, and then plus 1. And then on to step 3, which was rearranged to make y the subject. So for this one, I'd subtract 1 from both sides. If we do that on the right hand side, we get y over 5, the 1's will cancel. And on the left hand side, if we subtract 1, it's x take away 1. And then I have y over 5, so I can multiply by 5 on both sides. On the right hand side, this will cancel the 5 to give me just y. And on the left hand side, I've got x minus 1 there, and I need to multiply this all by 5. The best way to do this would be to put it inside a bracket, and then multiply by 5. So on to the final step, we can just replace that y with the inverse function of x. And then switch the order around, and there's your answer. If you wish, you could expand that bracket to get 5x minus 5, but it wouldn't matter. This would still be fine as your answer to the inverse function. Now let's try another one. We're going to do exactly the same steps. So change f of x for a y. So instead of f of x equals, it's y equals. Then on to step 2, which is replace all of the x's with y's and y's with x. So instead of y equals, it's x equals. And instead of x squared, it's y squared, and then plus 4. Now we move on to step 3. Let's rearrange to make y the subject. So let's subtract 4 from both sides. If you do this on the right hand side, that'll cancel the 4 to leave you with y squared. And on the left hand side, if you do x take away 4, that's just x take away 4. Now we're trying to make y the subject, and we've got y squared. So to undo that squared, we'd need to square root both sides. So if we square root the right hand side, you'll end up with y. But when you square root the left hand side, you end up with the square root of x minus 4. Now you'd be correct here to point out that when you square root both sides of an equation, you need to consider both the positive and negative root. So we could write plus or minus. However, when we're writing a function, we would never do this. This is something you touch on more at A-level maths, but a function needs to be well defined. This means that for each of the inputs, there can only be one output. And in this case with the plus or minus, for each input of x, you would have multiple outputs. So we just take the positive one, in which case we don't write plus or minus at all. So on to the final step, step 4. Let's replace that y with f inverse of x. And then we'll just switch that around, so the inverse function is the square root of x minus 4. Now sometimes in exams you get a question that looks like this. We haven't been asked to find inverse f of x, but instead inverse f of 2. To do this, we're first of all going to find the inverse function. So let's repeat those steps in the same way. Let's write out the function but replace the f of x with a y. Then we're going to swap all the y's and x's, so it's x equals the square root of 2y cubed plus 58, and then we'll rearrange to make y the subject. So for this one we have a square root on the right hand side, so the first step is to square both sides. If we square the left hand side, we get x squared, and if we square the right hand side, that will remove the square root, so we just get 2y cubed plus 58. The next step is to take away 58 from both sides. If you take it from the left, it's just x squared minus 58. And if you take it from the right, that will cancel the 58 and leave you with 2y cubed. Now we can divide both sides by 2. On the left hand side, that's just x squared minus 58 divided by 2. And on the right hand side, that will cancel the 2 leaving you with y cubed. There's one more step of rearrangement to do. So we've got y cubed on the right hand side, so we're going to cube root both sides. If you do that on the left hand side, you get the cube root of x squared minus 58 over 2. And on the right hand side, if we cube root that, we end up with y. We can replace y with f inverse of x and switch the order around, and there's our inverse function. Now remember, we didn't want to find the inverse function, we wanted to find the value of it when x equals 2. So all we do to find f inverse of 2 is write this function out, but replace the x's with 2. So it's the cube root of x squared, but we know that x is 2, so 2 squared minus 58 over 2. 2 squared is just 4, and 4 take away 58 is negative 54, and if you divide that by 2 you get negative 27. So it's the cube root of negative 27, which is negative 3. And that's your answer to this question. And now let's look at one more question for this video. In a previous video, I looked at composite functions, and this is a great topic to be mixed with inverse functions. Often in exams you'll get functions questions which assess multiple different skills in one go. So in this question we've been asked to find gf inverse of x. This means we need to do the composite function gf of x first, and then find the inverse of that function. So we're going to start by finding the composite function gf of x first. To do this we write out the g function, but everywhere we find an x we write brackets. So instead of x squared we write bracket squared and then minus 2. Then inside these brackets we write the whole of the f function, so we're going to place x plus 5 in here. And that's your function, gf of x. It might be tempting at this point to expand out this bracket, but it's actually much easier if we just leave it in this form. So we're now going to find the inverse of this function. So we do this in the same way we have all throughout this video. We start by replacing the function with y. So it's y equals x plus 5 all squared minus 2. Then we switch y's for x's and x's for y's. And then we rearrange to make y the subject. So I'm going to start this one by adding 2 to both sides. On the left hand side it's x plus 2, and on the right hand side that will cancel that negative 2, leaving us with y plus 5 all squared. Now we can square root both sides. If you square root the left hand side it's the square root of x plus 2, remembering again we don't need that plus or minus. And on the right hand side, since a square root is the inverse of squaring, we just get y plus 5. Now we can subtract 5 from both sides. On the left hand side, we've got the square root of x plus 2 and then we take away 5. And on the right hand side, this 5 will cancel, so it's just y. Then we can switch out that y, but instead of the inverse function of f, it's actually the inverse of the composite function g of f. And of course, we prefer this to be on the left hand side. So we end up with the inverse of this composite function as square root of x plus 2 and then subtract 5.